The third line of evidence that we're going to take a look at is comparative anatomy. And so anatomy, think of anatomy and physiology. So for example, the forearm, my forearm. I have my hand, my wrist, my forearm, my elbow, and then my humerus. Not so funny. But that's my anatomy. Okay, I'm going to compare my anatomy, or I'm going to compare the anatomy of one organism to another organism. In this example, we're going to have you interact with the evidence of comparative anatomy in a few different ways, okay? First, we're going to show you the forearm or the front limb of 6 different organisms: the human, horse, whale, turtle, frog, and a bird. And if you look at these images, you'll see that we color-coded them in order to show you the different bone structures, so the different actual anatomy. Oops, sorry about that, you guys. You'll see that in purple is the humerus bone. So all 6 of these organisms have a humerus bone. In the blue would be the radius and the ulna. That's actually 2 bones in most all of these organisms. The orange bones would be the wrist bones, or what we call the carpals. It's actually made up of lots of little bones in you and I in here. And then the metacarpals, which are your hand bones, which will lead to your fingers, which are your phalanges, and we'll just connect those 2 together. That's in yellow. And so take a look at these 6 organisms and look at the bone structure, the anatomy of their front limb. And you can see some really big similarities. So when we compare it, we're looking for things that are similar. The greater the similarity in anatomy, which is our body plan, which is written in our instructions, how our body plan is laid out, leads us to believe that there is greater similarity or relatedness. And so they have a closer common ancestor. And so what we're going to ask you to do is, the first thing we're going to have you do is go ahead and just think about, what do all of these organisms use these different things for? Okay? So for example, the human, what does it use its front limb for? Using tools, picking up and holding objects. A horse is going to use theirs for walking because they walk on all 4. A whale would use theirs for swimming, moving through the water, and so on and so forth. Is it used for flying? Is it used for jumping? Is it used for finding balance? So you're comparing the forearm. Then what it's going to ask you to do is go ahead and compare the skeletal structure of each limb to that of the human. So we're comparing it back to the human arm, just because the human anatomy is our point of reference quite often. And so relate the differences you see in form and the differences in function, because we're going to talk about, is it more important to have similarity in the form, in the structure, or is it more important to have similarity in the function? And you're going to find, as far as evidence goes for relatedness, ancestry, the greater the similarity in the form, the more related the organisms are. The more similar in function, which is called analogous, then it doesn't necessarily mean that those have to have a close common ancestor. That might just be their environment acting on them. And so you're going to go through, and I used the whale as the example. Comparison to the human arm in form, that's in structure. I said a whale has a much shorter and thicker humerus, radius, and ulna. So all the upper arm bones, or the arm bones, are a lot shorter and thicker. However, the metacarpals are significantly longer, except for that thumb is very short. When we look at comparison to human arm in function, the whale fin needs to be longer to help it move through water, and so it's spread out. So those phalanges, those metacarpals, can actually spread out in comparison to like the arm bone. And thinking about pushing through water, when we swim, we use our hands to help us push ourselves through water. And so a whale doing that, that's what it needs to be successful. Naturally, it would have developed and changed differently over time. So go ahead and go through. Once you're done with that, then we're going to look specifically at comparing anatomy of organisms where the two structures have the same function, but they don't have the same structure. And so we're using a bird wing and the wing of an insect, like a fly or a moth. An insect does not have a skeletal system, and so structurally, a bird wing and an insect wing are very, very different. The bird wing has bones in it. It actually has all of the bones that we just talked about. And so when we talk about function of these structures, both are used for flying. However, the bird has bone structure, whereas the insect does not have bone structures. Insects do not have bones. If we were to then say, okay, how about a bat? Would a bat be more closely related to a bird or to an insect? Well, a bat has bone structure, and so structurally it has greater similarity in homology and structure to a bird, which would indicate that a bird and a bat would be more closely related. Then you're going to compare the overall body structure, and we're going to look at a surface minnow and compare that surface minnow to a cavefish. And I have the image. The top one is the surface minnow, the bottom one is the cave. And if you notice on the cavefish, it does not have an eye. If you think about a cavefish is living in a very dark area, and maybe it no longer needed its eye. And so maybe that actually, without the eye, it had some form of an advantage. And so these structures that organisms once had but have maybe lost over time through evolution are called vestigial structures. These vestigial structures are interesting. We actually have some vestigial structures. If you think about our appendix, that is something that we don't really use anymore, but ancestrally, maybe our ancestors actually did use it. Our wisdom teeth is another vestigial structure that we actually don't use. Matter of fact, some of us are born without wisdom teeth, and most of us who are born with them have them removed because they are not serving us a purpose and actually can cause some problems. And so you're going to take a look at these vestigial structures. Then it's going to talk about, and here's where I really want you to kind of pay attention and spend a little bit of time just thinking about the differences. We have homologous structures, and so you could have a homologous structure. This would be like the forearm of a whale and the forearm of a human. Very, very similar in structure, bone structure, same bones, same layout, same plan, just maybe size, shape, a little bit different. Those are homologous structures. Then we also have analogous structures. Analogous, same function, but not the same form. Analogous structures actually don't help us in evidence to support relatedness. It typically does not indicate that two organisms are more closely related just because they have the same function. Structure is much more a much stronger piece of evidence. And then last but not least, definitely for evolution evidence, is vestigial structures. Matter of fact, if you were to look into some whales and you look at their pelvic region, you can see remnants of a femur bone. A femur bone is the upper leg bone. Why would a whale need a leg bone? They don't have legs. If you look at the evolutionary history of whales, it's believed that the ancestor to a whale once walked on land. And so these are our pieces of evidence for looking at homologous structures. Go ahead and fill out what's the possible function of some of these vestigial structures that we once had, and then it asks you which two organisms have a closer common ancestor, bird and an insect, or a bird and a bat, and I talked about that a little bit before. Go ahead and finish these questions and then come back and we'll take a look at homologous molecules.